All right, if you want to ace your exam, you're going to need to master two key things. First, we're going to unpack Thomas Kuhn's big idea about how science really changes. Then, we'll take that theory and put it into practice by showing you exactly how to build a killer research question. Let's jump right in. So let's start with a really interesting puzzle. Science is supposed to be all about logic and evidence, right? So why do new ideas get met with so much resistance? The answer, and this is key, isn't about bad data. It's about challenging the entire worldview of the people doing the science.
Kuhn calls this whole process a scientific revolution. Now, the word you really need to focus on here is incompatible. This isn't just about adding a new piece of information to what we already know. It's more like realizing the whole foundation has a crack in it, and you have to tear down a part of the wall to build something totally new in its place.
To really get this, Kuhn uses this amazing analogy. A scientific revolution is a lot like a political revolution. Think about it. In both situations, you have a choice between two completely incompatible ways of seeing the world. The old system, whether it's a scientific theory or a form of government, literally prohibits the new one from existing. So you can't just tweak it. You have to convince the whole community to let go of the old way and embrace a brand new worldview.
So what kicks off these huge revolutions? One word: anomalies. Just think of anomalies as glitches, results that the current dominant theory just can't explain. They're these annoying, persistent puzzles that scientists can't solve, and eventually they create a crisis that opens the door for a brand new way of thinking.
But really understand this, we need to be clear on what Kuhn meant by a paradigm. It's so much more than just a theory. It's the entire rulebook for how science gets done in a particular field.
And this leads us to a super important question for your exam. Are theories just our human interpretations of raw objective data? According to Kuhn, the answer is a hard no. The paradigm you're working within actually changes what data you even see in the first place.
You know, a good way to think about a paradigm is like an operating system. It dictates the theory, what exists in the universe and how it all works. It sets the methods, which tools and experiments are legitimate, and it defines the standards, what even counts as a good question or a valid answer. It controls everything.
And because a paradigm is so powerful, changing it isn't just about rethinking the facts. Kuhn says it actually causes a perception switch. When the paradigm shifts, scientists are, in a very real way, living in a different world. They literally see things differently.
This quote nails it perfectly. What you're trained to see is what you see. Take Uranus, for example. For ages, astronomers looked right at it, and the light hitting their eyes was the same, but their paradigm told them they were seeing a star. After the paradigm shifted, they looked at the same point of light and saw a planet. Same data, totally different perception. Okay, so if scientific revolutions start with anomalies that the old paradigm can't handle, how do you find one? Well, you do it by asking the right kinds of questions. So let's switch gears from theory to practice and look at how you can build a question that might just challenge the way things are.
For your exam, you have to remember these three things. A great research question has to be important. It's got to connect to a bigger conversation. It has to be researchable, meaning you can actually go out and find an answer. And of course, it has to be original. You're trying to add something new to the discussion, not just repeat old news.
And to help you do just that, here's a really practical tool you can use. It's called the VACE model, and it's a great step-by-step guide for creating a really sharp, focused research question.
The model is super simple. It's just 3 steps. You start at the wide top of the vase with a big, broad topic. Then you narrow it way down to the skinny neck of the vase with a very specific, researchable question. And finally, your conclusions broaden back out at the base, showing how your specific answer helps us understand that original, bigger topic.
Let's look at an example. You could start with a massive question like this. It's definitely important, but there's no way you can research it effectively. I mean, where would you even begin? This is the top of the vase, way too wide. So we use the model to get specific. This is the neck of the vase. See how focused it is? We're looking at a specific action, securitization, affecting specific groups in one country. Now it's focused, it's manageable, and you can actually research it. And here's the cool part. The answer you find still adds a valuable piece to that huge debate about the war on terror.
Okay, so you know how to structure a question. Now let's quickly cover the 5 types of questions you can ask. Knowing these categories is a huge advantage for your exam because it helps you understand what any piece of research is trying to accomplish.
First up, we've got descriptive questions. These are your basic who, what, where, when questions. They're all about just describing a situation and getting the fundamental facts straight.
Next are explanatory questions. These take it a step further. They're not just about what happened, they're about why it happened. They're trying to find the causes behind things.
Third, you have predictive questions. The name says it all, right? These use what we already know to try and forecast what's going to happen in the future.
Fourth are prescriptive questions. These are all about action. They ask, okay, so what should we do about this? They're focused on finding solutions and often look at different policies.
And finally, we have normative questions. These are the big philosophical ones. They deal with values, with what's right and wrong, with what should be, not just what is. We've covered a ton of ground really fast. To make sure you've got all this locked in, you can find the full summary of this material plus a bunch of practice tests to get you ready over at greatguru.nl. So, let's do a final, super fast recap. Here are your key takeaways for the exam. Number 1, science changes through revolutions. 2, paradigms shape everything a scientist sees and does. 3, a good research question is important, researchable, and original. 4, use that VACE model to get focused. And 5, know your 5 types of questions. Got it?
I'll just leave you with this final thought. Kuhn says all big changes start with anomalies, things that just don't fit the current explanation. So, now that you know how to build a good question, what anomaly are you going to choose to investigate? Good luck with your studies.